So you have 2 times negative 1, that's negative 2. Then we have 3 times negative I, that's negative 3i. So we get negative 2 minus 3i. In which graph is theta coterminal with an angle of negative 70 degrees? Okay, so whenever we're talking about angles, we always start on the positive x-axis with our spinner. So here's our little arrow, right? And in general, we usually move in this direction. That would be the positive direction, positive theta. But if we move it the other direction, that would be a negative angle. So, for example, negative 70 degrees would be down here in this fourth quadrant, right? In triangle ABC, so let's just sketch up a quick triangle. ABC, we always want to label it in a clockwise fashion. Measure of angle A is 74. Side A, of course, which would be opposite from angle A, side A is equal to 59.2, and side C is equal to 60.3. 60.3, okay. And they want to know what the two possible values are for the angle C. Okay, so this is going to be a law of sines question. So we know to use law of sines whenever the question is providing us with 3 out of these 4 pieces of information. Yeah, in this case, we have C here. So yeah, A over sine A equals C over sine C. And we're given 3 of these. So we're given the value of A, we're given the sine A, and we're also given the value of C. We just have to find the sine of C. No problem. Let's just plug in. So 59.2 over the sine of 74 equals 60.3 divided by the sine of C. So at this point, we'll need to grab our calculators. And let's see, so we'll do 59.2 divided by the sine of 74. Sine 74 equals. Alright, so that's our left side, 61.6 basically. 61.6 equals 60.3 over sine of C. At this point we can cross multiply, so we get 61.6 sine of C is equal to 60.3, and then we'd have to divide by 61.6. Right, so we can just take 60.3 and divide it by our answer. 60.3 divided by second answer equals. We get this. Now, so sine of C would equal 0.979. So at this point we can do an inverse sine of both sides, and that will allow us to solve for what C is equal to. We just have to do a second sine of this answer. Second sine, second answer equals, we get 78.27 degrees. 78.27 degrees. Now, this is a first quadrant angle, right? So it would look something like this, right? 78.27 degrees. But since we have ASTC, right, we remember that there are actually a total of 4 angles, all of which will have the same reference angle. So we have this situation. Now 2 of these, namely the A and the S, will both have a positive value for sine, right? So what that means is that this angle here, 78.27, and then if we are to go 78 short of 180, right, so what would that be? So 180 minus answer, we'll get 101.73. 101.73. This may also be a valid angle, And the way to check that is to see if you have enough room with the other provided angle, which was 74 degrees. So certainly we have enough room in that first triangle, right? So our first triangle here would be 74, and then over here we'd have 78.27. That's perfectly fine. And then the second possible triangle here, we'd have again 74, and this time we'd have 101.73. 101.73. So now, if we add these up, let's see what we'll get. So 101.73 is already in there, so I could just call the answer, and then add 74. And you notice that it doesn't equal 180 yet, so I could find out what's left over. 4.27 degrees. So that still can make a triangle. Now if we went over 180, then the second triangle would not be possible. So this is our triangle 1, this is our triangle 2. So this is called the ambiguous case for the law of sines, where you have two possible triangles. So it looks like 78 and 102 around there. So yeah, it's going to be choice 3. Okay. What is the principal value of the inverse cosine of negative rad 3 over 2? For this one, we could just use the calculator. So we can do second cos, then just write negative square root 3 in parentheses divided by 2 equals 150. So by principal value, they mean that they want the main one. So as we just discussed, we usually will have 4 angles, all of whom have the same reference angle, and 2 of them will have a positive and 2 of them will have a negative value for the cosine. So in this case, we are just looking for the principal angle. So usually it's a first quadrant angle. In this case, it's a second quadrant angle that has the negative value. Whereas, of course, the first quadrant value would have a positive rad 3 over 2. And if you recall